Good evening, class. We are looking at chapter 11, sequences and series. Here's section 11.4, the binomial theorem. And the objectives are to apply the binomial theorem. We've covered the sequence and series, arithmetic, and geometric sequence and series, and now the binomial theorem. So recall S sub n, the sum a sub 1 to a sub n of the first n terms of the sequence is a sub 1 all the way to a sub 3. Sigma is the Greek letter and indicates a sum, the sigma notation, summation of I going from 1 to n of a sub I, means add the terms a sub I beginning with the first term and ending with the nth term. I is the index of summation. A finite series, it's a sub 1 all the way to a sub n. S sub n equals to that, summation of I going from 1 to n, a sub I. An infinite series, it's a sub 1, but it continues indefinitely, and I goes from 1 to infinity. Summation properties, if a sub 1 all the way to a sub n, and b sub 1 all the way to b sub n are two sequences, and c's a number is a constant, then for every positive integer n, we have the following. Summation of c's and c. Summation of c, we can take the c times a sub I, we can take the c out, a constant c. Summation, when we have them adding or subtracting, we can cut them into pieces. Okay, so summation of a sub I plus minus b sub I, summation of a sub I plus minus summation of b sub I. Summation of I going from 1 to n is n times n plus 1 over 2. Summation of I squared is n times n plus 1 times 2n plus 1 over 6. Summation of I cubed is n squared times n plus 1 squared divided by 4. Arithmetic sequence and series. An arithmetic sequence, each term after the first one is found by adding a fixed number called the common difference to the previous term. That's an arithmetic sequence, a sub 1, a sub 1 plus d, a sub 1 plus 2d, and so on. The difference d between consecutive terms is constant, and the sequence can be defined by either recursively, a sub n plus 1 is a sub n plus d, or explicitly by a sub n equals a sub 1 plus n minus 1 times d. As you can see here, 1, we add 4, we get 5, 4, we get 9, 4, we get 13, 4, we get 17, and so on. The nth term is given by a sub n equals a sub 1 plus n minus 1 times d. And the sum s sub n is n over t, n over 2, a1 plus a sub n, or n over 2, 2a sub 1 plus n minus 1 times d, and that's the synopsis of those formulas. In the case of a geometric sequence or geometric progression is a sequence in which each term after the first is obtained by multiplying the preceding term by a constant non-zero real number called the common ratio. So in the case of a geometric sequence, we have a sub 1 times r, a sub 1 times r squared, and it continues. It can be defined recursively. A sub n plus 1 is r times a sub n, or explicitly a sub n equals a sub 1 r to the power of n minus 1. So that's the synopsis of what we covered. This is the synopsis of those equations. Now, S sub n is a sub 1 times 1 minus r to the power of n over 1 minus r. Of course, the denominator can't be 0. That's why r can't be 1. If r is any number between -1 and 1, as n becomes larger and larger, this goes to infinity, and eventually S sub infinity becomes a1 over 1 minus r. So in essence, let's say S sub infinity. So it's better to say. So as n goes to infinity, that's what happens. And now the new section 11.4, the binomial theorem, also known also the concept of a counting theory. Independent events. Two events are independent if neither influences the outcome of the other. Sequences of independent events can be counted using the fundamental principle of counting. Fundamental principle of counting says if n independent events occur with m1 ways for event 1 to occur, m2 ways for event 2 to occur, and so on and so forth, and m sub n ways for event n to occur, then there are m1 times m2 all the way to times m sub n different ways for all n events to occur. We'll get a simple example to make some sense out of this. If there are 3 roads from Albany to Baker and 2 roads from Baker to Prestwich, how many ways are there to travel from Albany to Prestwich? Well, from here to Baker, 1, 2, 3 different ways. Each one has 2 different ways to the final destination, Prestwich. Therefore, it's their product. Notice for each of the 3 roads to Albany, there are 2 roads to Prestwich. There are 3 times 2, 6 different routes from Albany to Prestwich. So this is one way. This is the second way. Third, fourth, fifth, sixth. That's the concept. A restaurant offers a choice of 3 salads, 5 main dishes, and 2 uh, desserts. Count the number of 3-course meals that can be selected. Basically, you multiply. The idea is the first event can occur in 3 ways, the second one in 5 ways, and the third one in 2 ways, the last one 2. So the product of 3, 5, and 2, that gives us 30 different possible meals. Okay, the factorial symbol and binomial theorem. Recall when n is larger than or equal to 0 is an integer, the factorial symbol is n factorial, which means this. You start from n and you go all the way to 1, you multiply. So according to the binomial theorem, we already know a plus b squared is a squared plus 2ab plus b squared. You may recall a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. That follows a binomial theorem. In general, x plus a to the power of n is n0, which is a combination of n choose 0, x to the power of n, n1, ax to the power of n minus 1, all the way to the last. So the summation notation for that x plus a to the power of n is the summation of r going from 0 to n factorial, r factorial, n minus r factorial, x to the power of n minus r, a to the power of r. And it's not always x, it may be it may not be a number, it may be just another variable. That's why. We will discuss that further in a moment. Reminding you what we did, 5 factorial simply means multiply 5 all the way to 1, which is 125 times 4 times 6. And 7 factorial is 7 times 6, 5, 4, 3, 2, 1. And you get 5,040. When the numbers get large, obviously you can use a calculator. The methodology is to use the factorial. So first you enter the value that you want, 5, 7, 10, whatever. And then you press math. Okay. And then PRB, probability, and then factorial. And it gives you, for example, 120. So going back, just 5 factorial and you're done. So I hope everybody is clear on as to how we do this. Permutation of n elements taken R at a time. A permutation of n elements taken R at a time is one of the arrangements of R elements from a set of n elements. If P and R or P and R, there are two ways to write it, P parentheses n comma R or P uppercase R and lowercase r. Denotes the P sub n R, this is upper, this is lower, denotes the number of permutation of n elements taken R at a time, or has to be less than or equal to n, and it becomes n factorial over n minus r factorial. What's important to know, order within the group of our object is important. That means, for example, AB is different than BA. Order is important. For instance, and the formula is n factorial over n minus r factorial. For instance, an ordering of 3 books selected from 5 books is a permutation. There are 5 ways to select the first book, 4 ways to select the second, and 3 ways to select the third one. Thus, P5 3 is 5 times 4 times 3, which is 60. Or you can say P5 3, which is n factorial, according to this formula, right? 5 factorial divided by n 5 minus 3 factorial. Okay, so I hope you see that the denominator is 2 factorial or simply 2. The top is 5 times 4 times 3 times 2 factorial, and so you get 5. So that's another way of doing it. You can do it with the permutation formula or just notice the multiplication rule. Assume 8 people enter a swim competition. In how many ways could the gold, silver, and bronze prizes be awarded? Well, it's a permutation because order is important. This is a permutation of 8 people taken 3 at a time. Order within the group is important. So it's not that if you're chosen, are you chosen as the first or the second or third? That's why order becomes important. So it's a permutation of 8 choose 3, which is 8 factorial over 5 factorial. Now, you could expand this, you could expand this. Okay. But the way I do it, since 5 is smaller than 8, I'm not going to expand 5. So I'm going to keep that as 5 factorial for simplification. This is the fastest way. And 8, I'm going to go with 8, 7, 6, and I stop at 5 factorial. So I can drop those. Now, you can see the same thing here, okay? And you get 336. So that would be a faster way, everybody. If you put it into a calculator, you go with the same methodology, okay? And then over here, math and so forth, this PRB, you have a choice of NPR or NCR. First, you have to put a number that you want. Then you click this one, and then they are. So for example, in this case, we would put 8, then we would look for NPR, and then we would put 3, see 8, NPR 3, and it gives you the answer. Again, when the numbers get involved, you can always use a calculator, but it's important to understand the concept. Combination of n elements taken R at a time. A subset of items selected without regard to order is called a combination. A combination of n elements taken R at a time, of course, R is less than or equal to n, is denoted by CNR. So you can put it in this format, parentheses n comma R, or C parentheses n comma r, and is sometimes read as n choose r, and that's n factorial over r factorial times n minus r factorial. Notice this means you really are dividing the permutation by r factorial, you're making it smaller because r is larger, normally larger than 1. Note order within the group of our objects is not important. Now, if we said AB versus BA, it's the same thing. Order is not important. Here's an example. How many different committees of 3 people can be chosen from a group of 8? So we have 8 people, and we want a committee of 3 people. Order is not important. We just want to pick 3 from 8. So it's a committee is an unordered set, the arrangement of people. Therefore, order is not important. Therefore, it becomes a combination. So I hope it's clear to everybody that what's the difference between the two. So we have n factorial, which makes it n factorial, 8 factorial, then 3 factorial, and this is n minus r 5 factorial, in any order you put that. Now, how do I simplify this? Well, 5 is larger than 3. Maybe you want to put the 3 first if you go with that. It doesn't matter. R factorial times n minus r factorial or n minus r factorial times r factorial. It means the same thing. So I'm going to keep this. And that means I'm going to go up here and say 8, 7, 6, and 5 factorial and stop. And I stop. But 3 factorial, I'm going to expand it. Notice what happens. I stop at 5 factorial. So I can drop those. And then 3 times 2 is the same as 6. So 8 times 7 or 56. And again, this is just, if you do it by hand, easily you can do it in no time. So in this case, again, you go with math, PRB, and then NCR. You've already put number 8. Now you pick 3, 8 NCR 3, and it gives you the number 56. And I hope everybody is comfortable with that. So it's very straightforward, everybody. All right. This notation means combination. CNR is n factorial, r factorial over n minus r factorial in any order. So this would be 4 factorial over 1 factorial times 4 minus 1 factorial. This is 3 factorial. And this is 4 times 3 factorial. They cancel each other. How about 5, 3? We put 5 factorial at top, 3 at the bottom, and then 5 minus 3 at the bottom. And this becomes 2 factorial. And we're going to expand this at 4, 5, 4, and stop at 3 factorial. These two cancel each other. 2 times 5 is 10. Combination, okay, 7, 5 against 7 factorial at top, 5 factorial times 7. 7 minus 5 is 2 factorial. And so 7, because the bottom has 5 factorial, we expand the top as 7 times 6 times 5 factorial. So these two can cancel each other. Okay. And the 2 factorial is 2 times 1. 3 times 7 is 20. 8, 0. 8 factorial over 0 factorial times 8 minus 0 factorial, which makes it 8 factorial over 8 factorial. 0 factorial is 1, and we end up with 1. So This was to do it by hand quickly. A few important things to remember, and you can try it on your own. In general, Cn0, for example, 80 became 1. So any number gives you 1. Cnn gives you 1. Cn1 is n. Cn over n minus 1 is n. And this is important. Nr, if you choose a combination of nr, the same as n over n minus r. In other words, if these two numbers add up to n, they are the same. Just to give you an idea before I give you the next one, if I said I'm making something up, okay, 10, and this is 10, okay. If I put 2 here, then 8 here, because they must add up to 10. I'm saying they are equal, and you can prove that. It's very simple. I'm going to leave it for you to prove this in general. Let's go with a different one. 12 equals 12, and let's say 4 here. Then you have to put 8. And in other words, what this means, combination of 12 choose 4 is the same as combination of 12 choose 8. And I hope it's easy to see that if you write this out. How do you write it? 12 factorial over 4 factorial times 8 factorial. How do you write this one? 12 factorial over 8 factorial times 4 factorial. So the denominator is the same, just commutative property of multiplication. I'm going to erase these and I'll give you a few more. So show that n0 and n equals 1. First of all, notice these two are adding up to n, so that n1 is n, and show this. I highly recommend you show all of them. It's very simple, class. Just follow this, okay? It really makes it a good practice. The binomial expansion, x plus y to anything to the power of 0 is 1, x plus y to the power of 1 is x plus y. We know this one, x squared plus 2xy plus y squared. We know this one, and so forth. These are some of those. And in general, it's x plus y to the power of n. So let's see what we want to add here. So notice, the expansion of x plus y to the power of n begins with x to the power of n. So you want 1, it starts with x to the power of 1, 2, x to the power of 2, 3, x cubed, 4, x to the power of 4, 5, x, that's what it means. And ends with y to the power of n. See, this one is y to the power of n. This is y squared, this is y cubed, this is y to the power of 4, this is y to the power of 4. So that's one thing we notice. The variables in the terms after x to the power of n follow the pattern x to the power of n minus 1 y, x to the power of n minus 2 y2, and x to the power of n minus q y cubed, and so on to y to the power of n. With each term, the exponent of x decreased by 1, and the exponent of y is increasing by 1. So basically, the exponent of x goes down and y goes up. See, 3 becomes 2, y becomes 1. 2 becomes 1, 1 becomes 2. So x goes down, y goes up, their exponent. In each term, the sum of the exponents must be n. Take a look. The exponent, this is n, right? 3. The exponent is 3. The exponent here, 1 and 2. 1 and 2, 3. This one is 4. 3 and 1. 2 and 2. 1 and 3. 4. This is 5. This is 5. 4 and 1. 3 and 2. 2 and 3, and so forth. And the coefficients of the expansion follow Kayam-Pascal triangle. Let's elaborate on this. And basically what they use, the coefficients in front are called binomial coefficient, which is a combination of n choose r. So you can put the CNR starting with 0, 0, 1, 0, 1, 0, 2, 0, 2, 0, 3, 0, 3, 0, and then go down this way, okay? Now the numbers will be as such. Now what happens then, the binomial coefficient are like, what happens is that this is 1, then you put 1 and 1, you add them up, you get 2. You add these 2, you get 3, okay? You add these 2, you get 3. As you go down, 1 and 3 is 4, okay? 3 and 3 is 6, 3 and 1 is 4, and so forth. And let me show you how we get to the next one so you can see how this thing works. for 5 and 6. So 1 continues, we get 1 here. Then 1 and 5 is 6. 5 and 10 gives you 15 here. 10 and 10 gives you 20 here. Okay. 10 and 5 gives you 15 here in between, not underneath. 10 and 5 gives you 15 here. Okay. 5 and 1 gives you 6 here. And then this continues again in 1. This is 1. This is 1. So add these two. Add these two, as I said, 6, 15, 20, 15, 6, and the endpoints are. Historical note, the triangle was known in China in the early 11th century by the mathematician Xiao Xian from 1010 to 1070. It was, I hope I pronounced his name right. It was also discussed by the Persian poet, astronomer, mathematician Omar Khayyam. I highly recommend you read about him. He's got a lot of nice poems if anybody's interested. I think Fitzgerald is the name of the translator. The triangle is referred to as the Khayyam-Pascal triangle, or simply the Khayyam triangle. Well, they lived 1,000 years ago. He lived only a few hundred years ago. So basically, Pascal stole it from them. End of this. Anyways, for any positive integer n, x plus y to the power of n becomes this, x to the power of n, which is n choose 0. Then n choose 1, x to the power of n minus 1 y, n choose 2, x to the power of n minus 2 y squared, all the way to the last one. If you go with x plus a, and by the way, the first one class is the same as n0 because n0 is 1. By the way, n1 is n. You should know that because it's helpful in a moment. We're going to use that all the way to the end. And in general, somewhere in between n, j is a to the power of j, x to the power of n minus j. Now, we can represent it in this fashion. X plus y to the power of n is the summation of n choose r, x to the power of n minus r, y to the power of r going from 0 to n. And if you expand this, it's n factorial or factorial, n minus r factorial. Useful combinations to remember. Cn0, this one is 1. CNN, this one is n. Okay, this one is 1. Cn1, Cn, so in other words, this is 1, this is 1, this is n. Okay. And again, Cn, n minus 1, remember n minus 1 and 1, they add up to n, so that's it. And nr is n minus r. In other words, if you want to calculate them, some of them are very easy to remember, and some of them you don't have to recalculate again. You can use this fact. We will look at an example memo. So we want to write the binomial expansion of this, reminding everybody that this is what we use. This is the expansion of the combination. And if you do it like so, and these are the useful combination formulas. So x plus y to the power of 9. The first one is n0, which makes this x to the power of 9. The next one is 9, 1. 9, choose 1, x to the power of n minus 1. That means 8, y to the power of 1. So that's x to the power of 9. Or just, class, you could write here C n0, which in this case is 9, 0, right? Which is 1. That's why I didn't write. The next one is, again, don't forget the n is 9 for us here, okay? And so the next one would be 9, 1, x to the power of 8, y. The next one would be 9, 2, x to the power of 7, y squared. Again, the exponent is 9. This one, the exponent is missing with 1. 1 and 8 is 9, 7 and 2, and continue. The rest of it, I'm not going to go through them one by one. It's the same concept. Okay. So obviously, this is x to the power of 9. 9, 1. You can work it out, but remember, so 9 factorial over 1 factorial times 8 factorial. But we've already mentioned that Cn1 is n. So this is n, 9. Do you follow what I'm saying? We should know that. So we should know, and as you can see, this becomes 9, because this is 9 times 8 factorial, they cancel it. So you don't have to worry about that. The next one is 9 factorial over 2 factorial times 7 factorial. The next one is 9 factorial times 3 factorial, 6 factorial, and so on. So this is the next one. This is the next one. These are the next ones. Now, what I want you to know, this, I'm going to show you a couple of things. Of course, this has X number 1 here, right? So this must have number 1 here. This has number 9 here. This has number 9 here. Okay. So you work this out just for the sake of argument. 9 times 8 times 7 factorial, because the bottom has 7 factorial. And then 2 factorial is simply 2. There's 2 times 1. These two cancel each other. This is 4 times 9, 36. This becomes 36. Now, what I want you to see, class, 9 factorial over 2, or just look at this one, 9, 2. 9, 2 is the same as 9, 7. 9, 2 is the same as 9, 7. So this also is 36. So that cuts your work in half. And these are the answers. Okay. So let me erase the work and show you a couple of things. This one is the same as this one. 9, 4 and 9, 5 are the same. 9, 3 and 9, 6 are the same. And so forth. Okay. So I hope it's clear to everybody. So it's pretty straightforward, everybody understanding how this expansion thing works. All right. We are going to follow that. If you want to go with that concept, x is a, y is minus b over 2, n is 5. So if you want to raise this to 5th power, the first one to the 5th power, then 5, 1, a to the power of 4, this thing minus b over 2 to the power of 1. The next one, so we have this one, 5, 1, a to the power of 4 minus b over 2 to the power of 1, which we don't write. The next one plus 5, 2, 5, 2, a cubed, this thing to the power of 2. The next one, 5, 3, a squared minus b over 2 to the power of 3, and the rest of it. So this is 5. You can work on 5, 2, and then you don't have to work on 5, 3 because they become the same. This, everybody, we should know. Let me just write with a different color. So this is obviously 1, this is 5, and this again We should know it's 5. Then you have to calculate, these two are the same. Let's just calculate one of them. 5, 2 is 5 factorial over 2 factorial times 3 factorial. So I hope you see that if you put 5, 3, it's 5 factorial over 3 factorial times 2 factorial. So the bottom, I'm going to keep the 3 factorial, and 2 factorial is 2 times 1. And the top is 5, 4, 3 factorials. And we can drop those. 5 times 4, 20 divided by 2 is 10. So this is the 10 I was talking about. Okay, everybody. And we can see all of those. I hope everybody is fine with that. It's very straightforward, everybody. So we see where these these numbers come from, and we should really have no problem with those. Okay. Now, what happens is we have to expand them and pay attention to what? To the following. This one, multiply the 5 by negative 1/2. So this becomes negative 5/2 a to the power of 4b. This one, negative 1/2 squared is positive 1/4. So positive 10. Okay, so let me just focus on this one so you see that this one, class, 10 times negative 1/2 squared, that means 10 times 1/4, that means 5/2. And you can figure out the rest. Okay, so let me erase my work again so you see how we arrive at those answers accordingly. Obviously, this one, negative to the power of odd, remains negative. Negative 1/2 to the power of 5 is negative 1 over 32. So that should be clear to everybody as to what's going on. A little, if you try just a few of these, you become comfortable with them. Find the fourth term of a plus 2b to the power of 10. We'll look at it in different ways. Okay. The rth term of the binomial expansion, I going from 0 to n, or r going from 0 to n, ni x to the power of n minus I of y to the power of I. Please understand, over here we use r, over here we use I, makes no difference. The reason we are using different because we want to discuss the rth term of the binomial expansion is where, of course, n is larger than r minus 1. N over r minus 1, x to the power of n minus r minus 1, y to the power of r minus 1. Term containing x to the power of j is n minus j, x to the power of j, y to the power of n minus j. I'll show you that one, and I'll show you an easier way that you don't have to memorize this. Okay, so let's quickly look at the methodology. Obviously, n is a 10. The fourth term, r is 4, x is a, y is 2b. So that's that. One way is that you expand it and you just make a note of the fourth one. Okay, again, one way, just expand this. When you get to the fourth one, you have the answer. The other one is that you follow this formula. So n over r minus 1, we are following this, n over r minus 1, x to the power of n minus, the parenthesis r minus 1, y to the power of r minus 1. So replace the n with 10, r with 4, x with a, and y with 2b. Or here's and we'll find out what it is. Or the easier way, we said a plus 2b to the power of 10, according to the formula, is this, right? 10 fact is r goes from 0 to 10. We are looking at the general formula. 0 to n, which is 10. 10 factorial, r factorial, 10 minus r quantity factorial. A to the power of 10 minus r, and y to the power of r. Y happened to be 2b. So if you look at the first term, r is 0. Because the first term, we have a to the power of 10, and this doesn't have any power. The second term, r is 1. And the third one is 2. The fourth one is 3, and so forth and so on. So you recognize the fourth term, r is 3. If you want a specific term, okay, then you take off 1. So now 10, combination of 10, 3, combination of 10, 3, a to the power of 7, to be quantity cube. Okay. Now 10, 3, you work it out. This is a to the power of 7. This is 8b cubed. 10, 3, 10 factorial over 3 factorial times 7 factorial. I put 10, 9, 8, 7 factorial. I put 3 times 2 times 1 times 7 factorial. See, notice I choose to keep the 7 because it's larger than 3. Okay. And then I can get rid of the 3, make this one 3. 8 becomes 4. 2 goes away. And 12 times 10 is 120. That's what we have here. Times 8, 968 to the power of 7b cubed. You don't have to do this by hand, but I'm showing you doing it by hand is really not too bad, everybody. It's not that difficult. Use the binomial theorem to expand this. This is a simple case. 4, 0, 3y to the power of 4. You don't even have to write that. This is 1, 4, 1, 3y cubed, 2 to the power of 1, 4, 2, 3y squared, 2 to the power of 2, and so on and so forth. We should know this is 1. We should know this is 4. Okay. And this is 1. We should know this is also 4. So nr is n minus r. So this, if we know it's 1, this we know is 1, this we know it's 4, this we know it's 4. All we have to calculate 4, 2, which is 4 factorial over 2 factorial, 4 minus 2 factorial. And this is just 2 times 2, 4. This is 4 times 3 times 2, 3 times 2 becomes 6. And so plug in 1 times 3 to the power 4 is 81 y to the power 4, 4 times 2 times 27, because we have this number, plus this 2 is this one, 27y cubed, and then 6 times 2 squared is 4, 9y squared, 4 times 2 cubed, which is 8, 3y, and so on. And we end up with the following: 3y plus 2 quantity to the power of 4 is 81y to the power of 4, 216y cubed plus 216y squared plus 96y plus 16. And I believe that's pretty straightforward, everybody. So I hope nobody has any problem with that. All right, we want the 7th term of y plus 3 to the power of 8. So if we go with this process, we need to find n which is 8, or the seventh term. X actually is y here, and y is 3. And so to find the seventh term, we do this. Replace the n with 8, r minus 1, 7 minus 1. X, remember, is y here, n minus 7 minus 1, y to the power of 7 minus 1. And again, what is the second method? The second method is to write this formula. Y plus 3 to the power of 8 is the summation of r going from 0 to 8. 8 factorial over r factorial times 8 minus r factorial, y to the power of 8 minus r, 3 to the power of r. So the first term, r is 0. The second one is 1, and so on. So the seventh term must be 6. Therefore, or replace the r with 6. Okay. So this one is combination of 8 choose 6, y to the power of 8 minus 6, 3 to the power of 6. So this is 8 factorial over 6 factorial times 2 factorial, 6 factorial times 2 factorial, y squared 3 to the power of 6. This one, we go with 8 times 7 times 6 factorial. 3 to the power of 6 is 729. And these two cancel each other. 2 factorial is 2. 4 times 7, 28 times 7, 29. We get 20,412 y squared. It's pretty straightforward, everybody.